Yep.
Okay, so thank you for having me and for the nice introduction, Vanessa. It's a pleasure. It's and good morning, good afternoon for everybody else who is here. Team is around. It's very nice to see him after a really long time. So I'm talking a little bit about the estimated adult mortality when we have defective data, and I'll talk more about a few type of methods and give some examples for the case of Brazil and African country in Mozambique. And this is related to work I've been doing with several people over the past few years. So it's where do we stand? What's the problem we need to deal with? I'll go back here. So this is the 2017 United Nations Statistic Division. It's the coverage of death registration all over the world. So we see this, the really dark green countries, the countries with good data, and as we go to the white, the light blue, we have the very poor quality of information, and the white countries, they have no information. So it's an important task that we need to think of a way to estimate adult mortality, maternal mortality, or different age groups mortality with this limitation of data. So in general, we have this problem with the incomplete CRVS systems, or the census data might have some problems and issues, and we might have limitations with information of the age of the population. But we need to find a way to estimate it, because we need proper mortality estimates. So during the COVID pandemic, this was a big issue, how to estimate, and this goes in line with what Vanessa said. I'm part of the UN TAG group. I'm on working group 2 that is led by Stefan Hellinger from the NYU. And we're working on the alternative ways to measure adult mortality in countries lacking CRVS, so using census surveys and other methods. So we need the proper estimates. The estimates are important if we want to forecast the mortality. And this huge project on the burden of disease, the big part of it is to produce the what they call envelope mortality. But for any other countries that we need to do we want to do proper analysis of mortality, we need to think of ways to get those estimates. So this is and for the COVID-19 pandemic, this was a big issue. We have for several countries and using models to estimate COVID mortality, and countries where the vital registration systems were really affected by the pandemic. So we don't know if the quality of information
Bernardo,
works. And then,
Bernardo?
Yes.
Sorry, let me just interrupt you very quickly, because the internet seems to be a bit poor, the connection. Would you mind just turning off the camera while you speak so we can listen to you more clearly?
Yes, no problem.
And then you come back.
Okay.
Thank you.
Sorry. And I use the cable instead of the Wi-Fi to avoid this problem. Is it better now? Okay.
Yes, much better. Thank you.
So this is the problems we face. So this is the general. So the idea in the TAG group was to work with countries with limited data, where CRVS are not working, and consider other ways to measure the impact of the pandemic, not to measure the number of deaths by COVID, but at least to have an idea what was the possible impact of the pandemic, especially in this area of the world with very poor data quality. So one thing that it's important to have in mind here is I'm talking mostly about completeness of the death records. So we assume that to measure how the event is captured in the CRVS systems, or in some cases in the census data. So it's not like a discussion of coverage. When I think of coverage, we can think of if the system covers the whole population, or if there's any populational group that is not covered by this, considered by the system. So we might have like some ethnic groups that are not covered by the group, but we think of cases that we have the system that it should be available to everyone, but it lacks a little bit of quality. Just a step aside, so I'm just showing this some of the motivation and my interest on this topic. On the left side, it's like a 10-year-old interview by Ken Hill, and he was talking about the use of census to estimate adult mortality when in the discussion of the inclusion of household deaths in the households in the past 12 months. And it's a nice quote saying that it's important to have not to take it for granted the estimates, but to have a feel for the data and to have an idea of what might be going on. And on the other side, it's a picture of Bill Brass that several of the methods I'm talking about were developed by him, or in many other areas, not only mortality, but also infertility. So this is just a side step on the motivation and interest and relevance of the topic. So the main thing I'm talking about today is the death distribution methods. So the idea of the methods is that we are comparing the distribution of deaths in the population by age with the age distribution of the living. So normally we think of the methods that estimate mortality on some sort of kinship. So census include questions on if your siblings alive, or children ever had and children alive, and try to estimate infant child mortality and estimate adult mortality. In this case, we have some of the information on mortality, the age pattern of mortality, death counts by age. We have a population by age. This is good. We can use the existing CRVS system. We can also use census data when available. The advantage of it that it provides an age pattern of mortality. So we have the whole mortality schedule. We have a clear reference period. So if you're using the census data, it's that census year, and the data is there. But there's several assumptions that we need to make, and the methods might be very sensitive to those assumptions, and they might impact a lot on the results. And given the assumptions and the data quality, we might make choices that are not the best ones, because we are not aware of how sensitive to those choices are, and we can be working with one country and have two people having quite different results because of some choice that were made during the analysis. I'll talk a little bit about the methods, because the demographic idea of the method really nice, and they perform quite well on a series of countries. So what kind of data we need? We need two population age structures. We can get that from census, but it's also possible to use household surveys on other sources. We need the death counts by age. We can use the CRVS systems. There are a lot of studies using household deaths in the previous 12 months, and also studies using other household surveys that ask questions on deaths in the defined period of time. So the advantage, as I mentioned before, like using sibling survival, that we don't need to use a model life table or anything related to that, and we have a clear specific period of reference instead of producing estimates of a specific age group in the recent past. So the advantages of those methods, I think those two. So the first method it's very used, and has a really nice demographic idea is the general growth balance that was derived from the original growth balance that was proposed by Brass. So the idea is based on the basic demographic equation, so that we have the population year 2 is equals the population year 1 plus the births minus the deaths. And we can do the same for in rates. So we can have the rate of change in the population between year 1 and year 2, it's going to be the same as the difference in the rates of entering in that population minus the rates of exiting the population. And we can do that for each age segment. So in the basic demographic equation, we do that for the whole population, but we can think of that for any age segment. So population age 10 and above, it's going to be the population that was 10 and above already, plus those turning 10, minus those who died in the period. So the method has a strong assumption of the closed population of very small migration flows. And we can think of entries in each specific age group as births, if we were thinking of the total population. The exits are only the deaths. And we can produce the residual estimate of the mortality that we're going to obtain from the population age structure. So the entry rates at each age segment minus the growth rate of each age segment, it's going to give us the residual of it's going to give us what should be the mortality rate from that segment A and above. And we're going to compare this residual estimate to our observed death rate that we're going to get from the CRVS and the population age structures. So the idea is just the estimation here, how we estimate the entry rates, the growth rate in a regular way, and the mortality rate. So this is I think it's a very intuitive, it's very nice, and gives us a strong, show us how we can use the demographic relations to obtain an estimate of mortality and how to evaluate data quality. And then if we have our data with some incomplete death records, and if the quality of census change from one year to the other, we going to be able to compare the death rates we obtain from the residual, from the entry rates and the growth rates to the death rates that we calculate from the observed data, with a difference that will give us the level of completeness. So if we have really good data with a high level of completeness, this should be close to 1. And if we have data that it's not very good, we're going to find that here. So this is very nice. This is a really straightforward way to estimate, but we see that we need a additional step on looking at what the final estimate is. And also the general growth balance that was proposed by Ken Hill, it will also give us the level of coverage of the second census in related to the first census. It's not going to tell us if the census are good or bad. It's just going to tell us if they both have the same level of completeness. So that's also an additional interesting outcome from the model. So in the end, we have our left-hand side, we derive that from the population age distributions from the census. So the entry rates for the age, the population growth rate from the segment, from the age 8 and above. We're going to have the K factor that shows the relation on the quality of census 1 and census 2. And we're going to get the intercept will give us the function of the slope will give us the inverse of the completeness of death count registration. So intercept give us it's the function of any change in completeness of the census, and the C will give us the quality of information on the mortality death counts. We can use the mortality from CRVS, we can use the mortality from census data or any other source. So this is very useful. We now normally have this type of data for several countries, and we can work on this method in different contexts, and I'll show some results for different scenarios. So this is the general growth balance, the main ideas of the general growth balance. The second method is the syntactic extinct generations, is also known as the Bennett-Horiuchi method. The original idea was proposed by Vincent in 1951 paper, and he shows that if we in a stationary population, a life table, we have that the survivors at age A, they're going to be the same as the number of deaths from age A and above. So we can find, the idea is that we can find the stationary population in any age from the number of deaths we have from that age on. If we are in a stable population, we can have the same, and we just need to adjust the deaths above age A to the population growth rate. So in the case of the stable population, we use the same rate for our age range, and then we are changing and we adjusting for the cohort size for each birth, but we also get from the death that happened from age X and above, we can find the population at age A. And in this method, what we do to estimate the death counts registration completeness is to compare the population that we obtain from the death counts to the population we have from our data, from our census. So we're comparing N hat to N. So one we take from the deaths, the other one we have the information, and if the data quality is complete, we're going to have a factor of 1. But in most cases, we don't have the stable population, and then Bennett-Horiuchi, they generalize the method to any closed population and just using the variable R method. So we can estimate the population age A from the deaths above that age, and we just adjust it by the growth rates that we obtain from the 2 census, and this will consider the change that are happening in the population over time. So, and then we do the same comparison. We compare the population age A that we estimated from the death counts to the observed population from our census, and this ratio will give us the level of completeness. And then there's an additional method that's basically a combination of the 2 methods. So in 2009, Hill, Yu, and Choi, they did a series of simulations on how the assumptions of the method affect the results, and they proposed a combination of the 2 methods. So the idea is to first use the general growth balance to adjust the level of coverage of both census, and then with this new data, with this adjusted data, they suggest applying the Bennett-Horiuchi and then use the Bennett-Horiuchi estimate of completeness to correct the data. And there's an alternative way to do this, was proposed by Rob Dorrance and Tom Moultrie in the somewhat around the same time. They call it the Saga Delta, and with quite similar results. And it's an idea that was actually discussed in the Bennett-Horiuchi paper, and it's quite elegant the way to work with it. So we have like those 3 methods. So the main thing that we don't have one method. They have different results. They are affected differently by the assumptions. So if there's a question, which one should I use? The best way around is to use all the methods and see how they work. So one main thing that we need to consider now is that we're going to obtain how we're going to estimate the level of completeness. So if we see here in the Bennett-Hurwitz, the syntactic extinction ratio, we're going to have a series of ratios of n hat over n all over the age range, and we need to think of which age range should I use. So it's really important to look at the diagnostic plots. I'll show some soon, and then see how the assumptions might affect the results and what alternatives I have to obtain my estimates. So in the same paper here, you enjoy they did a series of analysis. They compare different methods and how the assumptions affect the methods. And they suggest the use of age range 15 over and 55 over. And Murray and colleagues in 2010 did a series of simulations, and they suggested a similar age range. In 2017, Hill suggests avoiding ages with more migration flows that would affect the results. So this is not like a gold standard that do this for all your countries and regions that you get a good estimate. This not there's no cookbook for that. So this is an example of the diagnostic plot. So this is the case of São Paulo in Brazil, using the general growth balance, the 2010, the census data. So the pink line is the adjusted estimates, and the blue ones are the observed, the actual estimates, and we want to estimate the intercept and the slope to have our census function and also the level of completeness. And we see for São Paulo, it looks quite good. We have the K factor, it's around 1, and the C is also around 1. So it's like São Paulo has quite good data in Brazil, and the census quality it's very good. So we're okay for each age, for any age range we choose here, we will get quite similar results. But then we might have something like this. So this is the case of Honduras, using data from 1998 and 2001. The red line is if we have 100% completeness, and the blue dots is what we observe. So in the y-axis, we have the residual estimate of mortality, and then the x-axis, we have the observed mortality rate. So in the case here for Honduras, what we have is that the residual estimate of mortality, it's almost twice the observed date. So for this case in Honduras, we estimate the level of completeness of around 55 to 60%. So we see that in the graph that there's a very high under registration of death counts, and also it's not so bad that there's a quite straight line that we can use to estimate the intercept and the slope. And we have really weird case. So this is Nicaragua from 95 to 2005. It's the same. The x-axis the observed death rates, and the y-axis our residuals. And in this case here, we have the opposite. It's like we have over-registration of death counts. So the data we have, when we compare it to the method, it's like we're having more deaths happening than we should have. And there's this, it's not like a very straight line as before. We have this part here, and then it goes down. So this the type of problems we face when using data like this. This could be a problem with the assumptions, could be more problems with the data than we expect, and that we need to work with. And this and this is again in Brazil. So the state of Maranhão has it's known for having a not very so good data quality. And so in 2010, the same as São Paulo, and we see a big difference here. So Maranhão has under registration of that count, and contrary to São Paulo, we find this relation in the earlier age range, that it's very linked to migration flows, that it's one of the characteristics of the state. So as I mentioned before, to calculate slope and intercept, we probably would consider, we would not consider those age ranges. We would work with the ages above here to get our estimate. And then an additional question arises, what we do with the old age groups. And just another example here is the case of Mozambique. In the 1997-2007 census, those estimates using the Bennett-Horiuchi for the country and different regions. And we see like this low level of completeness, this death report in the census, so around 60%, but with some variation across regions. The middle of the country has a worse data quality than the north and south. But then we see a more of a straight line. It's quite a nice estimate that we obtain with the census. And I showed the methods, all those, they saw it was done using Excel. And a few years ago, this package that was developed by Tim Rife and Everton and Peter Johnson, and this produced using the methods and the hybrid, and allows for a series of alternatives and a way to look at the diagnostic plots and test different estimates. And it's a really nice alternative to get the results using the DDM methods. There's some additional methods that I'm not talking about today. And also there's Kausch-Mertman and Marcos Gonzaga, they propose a Bayesian model to estimate age-specific mortality in areas with defective data. And Tina Adair and Alan Lopez propose an empirical method to produce estimates of completeness of death counts. So there's different ways to analyze. Now I'll show some of the examples and additional issues that we face. So here's the case of Brazil for the country. Just we see that's improving over time. The level of completeness is higher for males than females. This result is quite common in other countries in Latin America. Peru has a similar trend. Ecuador has a similar trend of showing higher completeness levels for males compared to females. And then in Brazil, we went level down. We look at the state level, applying the same methods, and then the assumptions, they start to play an important role here. So we need to assume that the population was close to migration, a very small migration flow. So we had to be really careful looking at the diagnostic plots to see what was going on for each of the states. But we see that as for the country, there's an improvement in data quality. It's better in the south compared to the northeast and north. And also this study was an interesting way to test different approach to the results. And then more recently, we were really interested, and there was a great demand for small areas. So we try to go area down in the case of Brazil, looking at the micro regions and see how it was going on over the country, the data quality, and also the mortality estimates. So the first thing we did was use indirect standardization, but it's full of assumptions and was quite problematic. And then we used the Topal's method that was based on the Beer method that was a modification proposed by Marx Gonzaga and Carl Schmettmann. Now we have a bigger problem dealing with closed population and very small migration flows because we're working with smaller areas. There are two ways we could use GGB adjusted for migration, and we opt to use a smaller age range to produce estimates. So instead of using the full age range, we went looking at the diagnostic plots to see what would be a better fit for the. And then in this work, we have estimates for the data quality for 137 regions. It was quite helpful to see what was going on in the country over time and space and the measure of health. And the way we did was to apply the Topal's regression model. And then with that, we obtained complete mortality schedule by age and sex. And then we applied DDM to evaluate data quality and finally to produce the estimates of adult mortality. So for this project, our data and codes and everything are available in this link to replicate. And here's just a few results. On that, this is the estimates for data quality, the completeness, so males and females, and we see a picture that's quite similar to the states. South and Southeast have better data in the beginning over time, and then spreads over the country. For the most recent period, we start reaching better data quality, but we still have several issues with regions with very small levels of completeness and regions with really large variations, like they show very high level of completeness in 1 year and then very low in the next year and then go up again. And this is also a problem and a question that we need to deal with. And then based on that, we're able to produce estimates of adult mortality and then adult mortality from the probability of deaths from age 15 to 60. And this gives a good picture of what's happening in the country over time. Mortality is declining. It's much higher for males than females, and where it's concentrated over time, and the rise of violence and the spread of violence in the recent years, and all this that we're able to do. And all these estimates, they start with the application of DDM to adjust the levels of completeness for each region. So I think I'll jump that because it's very specific. And one interesting additional thing that I would like to talk about is that there are several estimates from different agents, from different authors, and using different methods. And just to show the comparison of each of these, it's interesting. And I'll show just two figures and I'll come to a close. So this is the estimates of completeness of death count registrations by states in Brazil for males. So in the x-axis, we have the states in Brazil. The blue bar is the study that I did with Everton Lima, Marcos Gonzaga, and Flávio Freire. The black bar is the official estimates by IBG. And the red one are the estimates by HIME, the global burden of disease. So we just compared two extremes, 1980 to 91, and then 2000 to 2010. And then we can see how the difference on the estimates of data quality by, and the three estimates, they use the same methods. They use DDM with some variations. One limitation that we had in this comparison, we didn't have access to the complete methodology or the replication files, so it was hard to understand what could explain the difference, but we see the IBGE normally tends to have lower levels of completeness, and the variation from 1980 to 2010 from IBGE is the smallest one compared to the other two. And IH&E has really high levels of completeness in the 1980s, 1990s. And then there's this one difference that we can see for some states in Brazil. In our study, we found like completeness above 1, and IH&E limits that to 100%. So they have really high life expectancy for those states in the area. And we argue that this is not good data, this is actually really bad data that is giving us this strange result in completeness. And one additional thing that we have is we can compare the different source and then obtain an estimate of adult mortality. Here I'm just showing it's an estimate of adult mortality using different source. So red dot is the GBD, IH&E. The blue ones are the ones I showed before the map for Brazil. The grayish one is IBGE. Yellow one is the Bayesian model by Carl and Marcus with the 80% credible interval. And the black ones, it's the CRVS system in Brazil without any adjustment. So this, just to give an idea of so for instance, the state of Maranhão that I showed that have the data not very good. So for IBGE, when we compare to IBGE with data source, this is the difference in adult mortality. So it's 0.18 without any adjustment, and IBGE estimates in 0.29. And then IH&E in 2010 is a small correction, so it's and our studies also a correction, but a little bit larger than IH&E. And then the study by Marcus and Carl gives a higher adjustment, but very different from both IH&E and IBGE, and this is very common from all the other countries. So just showing like the different methods, different approaches. We need to be quite careful because they can produce very different estimates. So coming to an end, so all this show that how it's important to the continuous development of the CRVS systems in all countries. It's still important to investigate the quality of data, information, and keep investing in how this process is made and keep it updated, and that we would be able to use additional methods and data. There's a rising question on what's happening at more advanced ages, even in countries, less developed countries. One thing that I didn't talk a lot, but for the tag group for the COVID, one discussion that we had was to think what would be the impact of including household deaths in surveys and census to try to capture the excess mortality related to the pandemic. This should not be considered a final solution, but it's an interesting and complementary alternative. And the statistical modeling should not be seen as a substitute for good data quality, for good CRVS system. So that's so thank you for listening to me, for the chance to to present here in the working group. I just put my contact, and this is a small quote by Bill Brasses. Those methods, they have problems, they don't work in all situations. We need to be careful with the assumptions and how the errors are made, and it's very difficult to anticipate what might happen. So in the end, it's only one single truth, but there's an infinite number of ways to make errors. So thank you so much for the opportunity.
Thank you so much, Bernardo. If you want to turn your camera on again.
Okay, I'll
so we
try
can
that
see you.
now. Yeah.
See if it works.
Sorry.
So we can see you now. Hi.
Okay, yeah. Sorry, I had my, I turned with my cable instead of Wi-Fi, but yes.
All good. Yeah, so if people have questions, either put them in the chat or raise your hand. Ariel,
Ariel, yeah.
Want to go first?
Hi. The title of the talk was to estimate mortality with defective data, but it seems you would need to have really very granular data to do the exercise that you did. So you needed at a very small level of geographical aggregation. You need to have sex. You need to have age. So maybe after trying to get data from very developing countries, this seems to be a much higher bar than the total number of deaths nationally. So how do you use this in a really countries where data is almost non-existent or doesn't have sex, age, etc.
Okay, so yeah, this is a good point. So it's like for countries with no CRVS systems in recent years, a lot of countries, including the census questions on household deaths and some household surveys, and this type of method is being used to try to estimate mortality. But then you're right, we need the information at least by age. And Tim Adai's and Alan Lopp's paper I've seen some work using their empirical method, and then they look only at the overall level of completeness. So because they use information on other variables instead of the variables, they give you an idea of what the level of completeness of that country mortality level, that it's an alternative. And there's some comparison, comparing their method in Brazil with DDM and also in Ecuador, and the comparison with smaller areas. And there's some, it's not very stable. Like for some areas in Ecuador, I know the paper by Andrés Peralta that he finds like quite reasonable level of completeness when he applied the empirical method. The levels are really low and they just don't make much sense. In the case of Brazil, the difference are smaller, but still there's, for some states, the quite large difference. But it's an alternative. So they relate the level of completeness to a crude death rate, infant mortality, and some measure of population age structure. That the idea is that you can obtain that from any source, and this is an alternative. Did I answer your? Yes.
Not really, but
okay.
There are other questions. So.
Cheeto.
Thanks, Bernardo, for the presentation. I had an experience with the methods in South Africa. So we were looking at estimating district mortality in the South African context, and we experienced quite a lot of challenges with applying the methods at a lower level. That's at a provincial level because of internal migration. So I wanted to know a bit about how you dealt with the issue of internal migration, because with South Africa, it's quite random, and we saw when we applied the methods at that level, the results were in a lot of cases producing estimates that were over 100%. So that's my first question. The other question is also around issues around the general completeness. So my understanding is the methods assume that completeness is sort of constant across age groups. Did you also take that into account in your models? And realistically, do you have differentials in completeness across age groups? Because we also found in our case that there was a lot of underreporting, especially at early ages, infants and those under 5. The third question would be, would you see these methods being used perhaps in a different scenario where we have completeness, but we would want to estimate migration? Do you think it could be some other use case for using these methods to estimate migration when we have completeness and completeness of death registration and population level data? Thanks.
So thank you for the question. So when we look at the small areas, the first thing we do, we smooth the age profile for those areas, because in addition to the under registration, we might have the issue of 0 death counts, so it's really small areas. And then when we estimate the level of completeness, we had to look at the diagnostic plot and then choose an age range that were not really affected by migration. So this might be a really big limitation on the results. If you use a larger age range, then we had like similar problems as you mentioned, the obtain completeness over 1 and related issues. Yes, we had to assume that the level of completeness is it's equal to our age. That's why we focus mostly on adult mortality, and we use different methods for mortality below age 14 and above age 65, and then we try to model to obtain the complete age range of mortality. But then yes, and for males and females, this might be an issue, that especially in the case of Brazil, how the death registration works, since for males, most deaths are by external cause, and they follow very specific procedure. So there's strong evidence that the quality of the information for the age range is better compared to other groups. And the last questions, yes, there's Ken Hill has a paper that builds on the GGB and showing exactly what you asked. Like if we have good information, we could use the residual to estimate migration. If you have population growth rate and mortality and I don't know by heart, but the idea is that we could use it. And when we tried the GGB, including migration, the idea was kind of from that was use a several step procedure and to try to incorporate migration into the estimate. So it's kind of working the other way around. So I think yes, possible.
Tom's next.
Can you hear me? Yeah. Okay. So, Bernardo, that was a very interesting presentation. I'm Tom Pullum with the Demographic and Health Surveys program, and Trevor Croft, who's also with DHS, is on this call. And this method seems applicable to DHS data. We get the estimates of death rates from sibling histories, and we have the population in the household survey. I'm wondering, apart from the issue of the relatively small number of deaths that we get in the sibling histories, do you see any limitations to applying this method to DHS data?
I was thinking more of the sample size that could be an impact. But then as we worked with small areas, we kind of dealt with small sample size using the topals to smooth and adjust the mortality levels and then apply DDM. And it worked well. So it might be interesting to compare with other estimates instead of using the. So like when we look at the smaller areas in Brazil, we didn't use the observed data. We adjusted before, so to have the information for all age and not a lot of noise, and then we apply DDM. So that also might be a possibility to work with.
Can I also ask about the age heaping? Some countries we have a serious problem with that. Would it be advisable to smooth the data before applying it, the method?
Yes, yeah, that's what we do for small areas in the countries we worked with, in the case of Brazil and other in Latin America. That's the approach we.
Good, thank you.
Follow.
Have Jenny next. Jenny, hi. Jenny, we can't hear you, but there's also a question in the chat I can read. Maybe you can write, Jenny, while I just read also this other question to Bernardo, which is actually similar to the migration, but not as a method itself, but more as an explanation. The question is, I was very curious about two facts. Do we have possible explanations on why women's death registration completeness is lower than men's? Is it only related to young age mortality? Also, how can there be a completeness greater than 1? Is it linked to migration or more a general reason like systematic overestimation of age?
Okay, so for the over 1, it's probably we're breaking the assumptions of the method, and it might be related to migration flows, and it also might be related to changes in the census quality from when we compare the two censuses. There's a big change in the quality, and large migrations, they might produce results like this. I don't have a clear explanation for the difference in gender. One was also mentioned in the question. So if there's a difference in how the male death count, mostly external cause of deaths, and then this is computed in a better way or in a different way, and this might impact the results. And I see José Monteiro is here, and he did some work with Helena Castanheira from Peru, and they found similar results, like the large gender difference. I don't remember if there was a clear, what was the explanation. And in Ecuador, Andrés Peralta found the same, but there's more like a speculative answer than a 100% certain explanation. So, and for Andres Peralta, the explanation was very similar to what we have with external deaths, and this might be impacting the results. But then one interesting fact that we found that when we look with census data, we find similar results. And census data, the households reporting the event, and we find better registration for males than females, even with individuals responding to the deaths that happened in the past 12 months. So I think this is an interesting issue on trying to understand the difference. I don't have a 100% certain answer for that. Sorry.
Can I just read this comment from Jenny on the chat because her microphone was not working and it's related to what you've just said. That she said, I just want to comment that we also need to pay attention to changes in the reporting system itself because the DDM gave an inter-census measure of completeness. Improvements in the reporting system may be perceived as stagnation and improvements in mortality. Felipe?
I apologize because I have troubles with my connection. Despite that, I follow your work, Bernardo, and thank you, Monica, for allowing me to expose my question. And my question is related with reconciliate register data. For example, in countries that we don't have a continuous information on populations to calculate their rates. For example, in countries like Colombia or even in Brazil, how we can reconcile the data of the administrative registers with the census data in order to get or to fill the gap between census. I mean, to calculate the rates. This is one of my question, and the other thing is related with violence. There are some parts, some areas in developing countries that you don't have the access to all the information, and there is a sub-register of the information. There is an underestimation of the deaths or the population, and in order to forecast population, we need to account these sub-registers. Maybe you have some ideas to do that. And I'm asking this because you are really close to the war in Latin America, and you are really close to the war to LA mortality, to Latin America mortality with Piedad Urdinola. So thank you so much.
I don't know if I can answer. So as Jenny mentioned, DDM, we obtain an inter-census estimate of the quality, and the idea that we adjust the level of mortality and would give us this a better way to be able to have better forecasts and estimate the population inter-census. I think this, if I understood correctly your question. Yeah, so this is an issue that now all the IBG is facing now, since our census was postponed and they need so one issue was to discuss the data quality in between census to make sure that the population forecast in between was okay. So I think this, it's important to forecast, because if we start from a low level and we don't adjust, then we'll go and have problems, I think. And just one that, because in La Mortalidad, we don't provide any adjustment. It's just the raw data. So like the adjustments we provide are quite small. Like it's to make sure that if you add columns and lines, they will give us the same number. And for the cause of deaths, we try to clean for some weird death count, the cause of death. So like we find like in some cases males with maternal mortality. So this, we don't do an adjustment like human mortality database do. It's more like the raw data. So I don't know if I answer your question, sorry, but we can exchange emails or something.
Thank you. Thank you.
I think given it's 5 past, we might leave it there. Obviously, a lot of interest in your talk, Bernardo. There were lots of really good questions. I want to thank you again for agreeing to give this talk. It was so interesting and really great to have someone working on defective data come and give a talk and sort of put these methods out there for other people to discover as well. So thanks everyone for coming, and sorry about the link problem, but I think everyone got here eventually. So we'll be in touch about our next meeting. And other than that, have a great day, afternoon, evening, wherever you are, and see you again soon. Thanks again.
Thanks, everyone.
Thank you.
See you next time.
Thank you.